Welcome everyone to this presentation. We are going to look at what we call matter. You have already seen that matter is anything that occupies space and has mass, right? That's something that we saw when we are having our first lesson in chemistry. And in that lesson, we saw that chemistry is actually the science that deals with the study of matter and how it behaves under different conditions. Okay? So we want to look into details of what matter is. We want to know the different states of matter. We want to know the behavior of the particles that make up matter in the different states of matter. Okay? So those are basically our objectives for this presentation. Anything that is around us, it can be this pen, it can be this computer in front of me, it can be the chair that I'm sitting on, or the table that you are using, the phone that you're using, anything around you, the book, everything that you can touch, that is basically matter. Okay? That is basically matter. But things that you cannot really touch and they can't occupy any space, you can't say that they are matter. For example, the feelings that you have towards your brother or your mother, these are feelings. These are things that you can't touch, so we cannot classify them under matter. Okay, so anything, regardless of what it is made of, that is matter. Okay, so we have 3 states of matter, and you already know this from your primary science. We have the liquids, we have the solids, and then we have the gases. Okay, usually the solids include the things that are hard, for example, the wood, the chalk, the blackboard, the pen, the book, okay, the chair, all of things fall under solids. And then we have the gases. You know that we breathe in oxygen, it's a gas. We breathe out carbon dioxide, that is a gas. We have also nitrogen, it's also a gas. Okay, and other gases that you look at in chemistry. You actually look at several gases. Okay, gases like chlorine, gases like nitrogen, and many others. And then liquids, okay, the things that you basically drink, and there are those that you can't drink, by the way. It's not every liquid you can drink, but at least you know that you drink milk, you drink soda, right? You drink water, okay, and then there are those ones you don't drink. Oil, for example, or petroleum. You have other liquids, such as you have some paints which are liquid. Okay, they are also there. So we have a number of liquids. Okay, being used for different purposes. And then let's talk briefly about one state of matter. That is not very common. Usually we don't study about it a lot at this level, but it is called plasma. Okay, this plasma is basically when you have gases that have been heated to high temperatures, or gases that have been subjected to high or strong electric fields. Okay, so what happens if they are subjected to these conditions is that they lose electrons from their orbits. And then when they lose electrons from their orbits, they become highly charged particles. Okay, and these highly charged particles, because they have lost electrons, they become positively charged. Okay, and then the electrons which have been lost, I guess they are moving freely. Okay, and this is what happens with the sun, the stars, and also the lightning. But the application of that knowledge is what we see in sunlight. Sunlight, we are having light because of these charged particles. So, for example, these lights that we have in this image here, they are made because of the knowledge to do with the plasma state, which we can say is the fourth state of matter. Okay, and this diagram here is illustrating lightning. That's what you have there. Okay. When talking about matter, it is very difficult for you to, or for even me who is teaching this, to explain some of the things, because there are terms that are coming in that are perhaps new to you. For example, electrons, where are they coming from? Okay, and we said that we have particles that are positively charged, and they become positively charged because they have lost electrons. I'm getting you lost, right? I shouldn't. What I'm basically explaining is that in anything, the examples of matter that we gave, everything around us that has space and that occupies space and has mass is matter, right? But what is within that that object that we are talking about? That object, regardless of what it is, it has what we call particles. And these particles, we call them atoms. Okay? And these atoms have other particles again. So these other particles are the ones that we call, we have the electrons that we said that are lost, and then we have the neutrons. The neutrons. This is EU. Okay, and then we have the protons. These are the particles that are found within atoms. Okay, so in this subsequent presentation or the subsequent slides, I'm going to be referring to particles, but these particles that I'm referring to are basically the atoms. So we are saying that all matter contain particles called atoms. Okay, so in solids, these particles are closely packed and they are held together by strong forces of attraction. Therefore, they cannot move freely. They can only vibrate, but when they vibrate in that same position. So, if, for example, this is what we have, it's the particles here. They are very close. Here, they are very close. You see that there are no spaces in between them. They are held together by strong forces of attraction. That means that when you, for example, heat, the particles will vibrate, but in that fixed position. Okay? This is not to say that you can't melt a metal. You can melt the metal, and when you melt the metal, it means that you have broken the forces of attraction in between the particles. Then the particles become free. So because the particles in solids are held together by strong forces of attraction, and the particles are basically very tight, it means that they can basically have a shape, okay, and a particular volume. Okay, they have a definite shape and volume. Okay, and then the other thing is, because of these strong forces of attraction, the boiling points and the melting points are higher. Okay, are higher for solids. And then the other thing is they have low kinetic energy. Kinetic energy is the energy that an object has when it is moving. Okay? Or the energy that is possessed by moving energy is what we call kinetic energy. So these particles are not basically freely moving, so they have low kinetic energy. And then because they are closely packed, it is not possible to compress them. Okay? They are incompressible. Those are the solids. And then we move to the liquids, which is the second state of matter that we're looking at. The liquids, for them, they are a little bit apart and they are held together with the weaker forces of attraction. This therefore means that they are slightly compressible. You can compress. That means that they have lower melting and boiling points compared to the solids. Okay, so they have some space, they are not closely packed, weaker forces of attraction. Therefore, it is possible for them to take up the shape of any container. Okay, they do not have specific volume and shape, but they can take up the volume of any container where you put those liquids. Okay, they have a kinetic energy that is slightly higher than those of solids, and they can be compressed slightly and lower melting and boiling points because of the weaker forces of attraction between them. And then for gases, what we see is that the particles are far apart, and that means they're compressible. Okay, they have high kinetic energy. That means also they have low density, okay, and weight. And they do not have any particular shape or volume. Okay, so those are the three states of matter that we have looked at. The emphasis is that matter is made up of particles, which we say they are called atoms. And these atoms are arranged differently in the different states of matter. In solids, they are very packed and are held together by strong forces of attraction. This makes them very hard to separate and also very hard to compress, and therefore they have high melting points and boiling points. Also low kinetic energy. For liquids, a little bit closer with the weaker forces of attraction. For gases, far apart, and they are freely moving. They are having high kinetic energy. Thank you for listening.